And so, good evening, friends, and thanks to this second class on Sunday. You must all be cursing me that I spoiled your dinner plans and all that, but it's okay sometime if you're taking some new training. So, this type of things are okay. So, thanks for joining today. So, I'm Shailendra Kadre, and as usual, I'm your host for this fourth class on NLP basics. So previous to this, we have covered 3 theory classes on NLP basics and a couple of classes on Python hands-on. Okay, so that's what we have already covered. So far we have covered lexical analysis and syntactic analysis, and this morning's session we started semantic analysis, the semantic processing. So we'll continue with semantic processing. This is second class on semantic processing. So these are the topics covered to be covered today. These will be covered. Python hands-on will not be covered today, but maybe tomorrow morning we'll have Python hands-on. But these are the 5 topics we are covering: and named entity recognition, which is called NER, with chunking, chunking is a step after NER. Then after we get into relationship detection between words. Then there are a couple of new concepts like term document matrix and co-occurrence matrix. So you might be thinking that this term of document matrix and co-occurrence matrix is something very big because names are very complex. But actually speaking, these are very, very simple concepts. And even a middle school student can understand this. So I'll give some example with numericals. So you should not have any challenge in difficulty in understanding. But only names are big, but the actual concept is very simple. So as usual in this class also, we'll discuss some very simple concepts. And tomorrow morning's class, we will have some Python hands-on. Okay. So today we'll finish our theoretical part of semantic analysis. And after that, we'll get into the Python hands-on. Okay, so first of all, let us get into something called NER, so named entity recognition. So entity we discussed this morning. Entity is nothing but a specific person's name or location's name or anything specific by name, like Hyderabad is an entity, like Ram is an entity, Shailesh is an entity, Shailendra is an entity. So these are entities. So named entities, like we are recognizing, like whatever sentence or document we have, in that we have a lot of named entities. So we talk about persons, we talk about places like New York, we might talk about some cities like Philadelphia, Bombay, Delhi, like that we might be talking about. And a lot of other entities we might be talking about. So this extracting these entities is very important in a certain business application, which we'll take up after this class. So after this class, we have a small 15-20 minute class on business use cases of whatever we have learned so far. So what are business use cases of US tagging? What are business use cases of NER? What are business case of co-occurrence matrix? These kind of things. So all the concepts which we have learned. So we will see what are their uses and how they are used. So we'll give a break after this particular class, and then we'll have a separate class on 15-20 minutes on the use cases. So use cases you will understand. So it is in medical terminology, it is medical world, it is very important. It is used in drug discovery, it is used in identifying genes and many other things. In name entity recognition is used. So name entity recognition, you can say, is the end product of your semantic analysis, and chunking and all is built upon named entity recognition. Okay, so named entity, NER is one of the data pre-processing tasks. So we know that all lexical analysis, semantic analysis, syntactic analysis, all are data pre-processing tasks, right? So NER is also, named entity recognition is also one of the data pre-processing tasks. NER identifies the key information in the text. So we'll see what kind of key information we are identifying. So basically NER deals with identifying the key information in text. So what kind of information that we'll see a couple of slides ahead. After that, NER classifies this key information, that what is the whatever key information we extract, that is classified into predefined categories. So it is defined into categories like entities and many other categories. It is defined that we'll see down the line. Okay. So like there are simple like there are two examples here. One is a bigger paragraph. The second one is a bigger paragraph, and first one is a sentence. So let us consider first sentence. So just read. It is a kind of tongue twister. So outs we were director Adam Newman lists his Manhattan penthouse for 37.5 million. So there are entities here. As you can see, it is they are listed below in green, and the colors are different colors. So WeWork is an organization, so it is also an entity. Adam Newman is an entity. It is name of a person. Manhattan, we are talking of a location in New York, so it is also an entity, location. And 37.5 million. This is also an entity. We are talking about monetary values. So these are the some predetermined classes in which we classify our information, whatever we extract. Now consider this particular sentence. So when Sebastian Thrun, Sebastian Thrun started working on self-driving cars at Google in 2007. Few people outside the organization, very few people outside the organization took him very seriously. Like it happens now, anything started very new, a very radical concept, so people will not take you seriously. So same thing happened with Mr. Sebastian also, when he started working on self-driving cars inside the Google. I can tell you very senior CEOs of major American car companies would shake my hand and turn away because I was not worth talking to. Very clear. CEOs were shaking hand with this Sebastian guy, and they were turning away because they thought that this person is not useful at all. Said Thrun. Thrun means might be his family name or something. In an interview with Record earlier this week. So okay, this is the sentence. Now the entities are extracted in and shaded in different colors here. They are highlighted in color. So Sebastian Thrun is the name of a person. So person is an entity. Google is an organization, so that is also an entity. 2007 is an entity because it represents dates. Then American is an entity because it is some entity called NORP, so related to location. Then Thrun again is there, then again representing person. Then Record A is some kind of organization, maybe some news agency or something which takes interview, who took interview of Sebastian. So Record A is again an organization, and earlier this week. So earlier this week is again representing date. So these kind of entities we are extracting out of our paragraph. So now it is very clear to you like what kind of entities we are going to extract out of our sentences. And these key entities, once we extract, we classify them into this predetermined category like person, organization, date, NORP, and then dated. So these are the very common entities. There are a few more, but these are the common entities in which we will classify our information, whatever we have extracted. So similarly, if we have a long document of 1 million words, the same thing we'll do with the entire document. So that this process is called named entity recognition, and in short, it is called NER. So these are the main entity types which you can read on the left, like organization, person, location, date, time, money, percent, facility, and GPE. So GPE is your Northwest America, something related to maybe GPS or something, I'm not sure. But
That's geographic position entity.
Yeah, geographic position entity, GPE. So it is representing Northwest America, facility Washington Monument. Percent is very clear to you. Money also very clear to you. Time also is clear to you. Date, again clear to you. Location may be Mount Everest or Manhattan or New York or whatever. Person may be President Obama or any President of India, like President of India, like and other Prime Minister of India, Narendra Modi. When we will specify Mr. Narendra Modi by his name, then it will come under person entity. So these kind of entities we are extracting. And this all work has to be done automatically. Use cases of this we'll discuss after this class in a separate small class, which someone will take. So this is the process of chunking. Now we are coming to chunking. So once we recognize entities like this kind of entities are, and see whatever this is represented here in the paragraph, shaded one. So this is generated automatically. Like this shading also is, we have tools to generate this kind of shading. Nobody does it manually. And all entities are recognized, and next to that entity, we specify the name of that entity and we shade it with different color. Okay. So this is also done automatically. Tools are available to do this. In any text you give, they will extract entity and shade like this. So that we'll see in tomorrow's class. So this kind of, then after that, the next step is chunking. So what is chunking? So chunking means, I will tell you what is chunking. So I will first take you to the example. So see the sentence. The sentence is the book has many chapters. It should be many chapters actually. So the book has many chapters. So this is the sentence. So first we do our favorite POS tagging, which is part of syntactic processing. That's what is done in the step one. Then we apply some kind of chunking rules to it. We just apply the chunking rule, but output is nothing. We try the second step, we apply the chunking rules. So right now, whatever you see is just in the bottom or just your POS tags. Then after chunking rules are identified, we like chunks. So chunks we are showing. So the book is a chunk, and many chapters is a chunk. So the book is a chunk and many chapters is a chunk. So chunk, you can, in layman's language, you can say that chunk is nothing but a phrase. So we are extracting phrases out of our sentences or our text corpus, and it is a stage after NER. So chunking to, again, tools are available to extract phrases. So the book is a phrase here, and many chapters is again a phrase here. So we found two phrases here. Okay. So this is how different step in different stages we do chunking. Then again I am representing it with a simple flow chart so that your understanding is clear so far whatever we have learned. So sentence segmentation we do, tokenization. First of all, a bigger paragraph is divided into sentences, and sentences are divided into tokens. We all know tokens in layman's words are nothing but specific words. Different word separated by a space, they are nothing but tokens. So then we do tokenization, then we do part of speech tagging. So till part of speech tagging, it is nothing but you are analyzing the structure of the sentence. Syntax you are analyzing. So it is syntactic processing. After that, we enter into semantic processing. So we do entity detection. So entity detection is nothing but your NER, named entity recognition, NER. So we enter from entity detection, we enter into semantic processing. And then the next part is chunking and relationship extraction. So that's what is your NLP flow diagram. Okay. So we have seen named entity recognition, we have seen chunking, and once you do the chunking, you do some kind of relationship extraction, which we'll see tomorrow in the Python class, that when we extract our chunks, we find the relation between the words, like which word is dependent on what word. So like some last word in a big longer sentence, some last words can be related to first word. They might be talking about first word. So that kind of relationship automatically we detect, and we have tools like DisplayC to represent that kind of relationship. So that we'll see tomorrow. Relationship detection we'll see tomorrow. So this is what is relationship detection. So relationship detection is very clear to you. Now, relationship detection is identifying entities, classifying the type of relation between them, if exists. And you classify the entities first in NER using NER techniques. And once you have entities, you find the relationship between them, if at all any relationship is there. Okay. So this type of can be relationship you can find in detail here. So I will take you to this particular link. I will take you to, and I'll show this is a documentation of very big documentation of see, I will make it zoom. So relationship annotation guidelines for relationship detection and characterization. So some kind of entire documentation, basic concept, physical entities, located, near, located. See, located is also one kind of relationship. Near is also one kind of relationship. Part whole is also a kind of relationship. Then personal, social, also relationship, business relationship. So these are the kind of family relationships. So these are the type of relationships which we expect. So employment, membership, subsidiary. So you have that, and the right side EMP organization is representing employment, membership, and subsidiary. Then you have employee executives, then you have employee staff, then lot of entities are there. You can see lot of entities are there. So we are not much concerned about this, but whenever you want any bigger representation, or whenever you want to understand in detail, so this resource can be very useful, because it is a complete listing of all kind of entities, all kind of relationships which are detected using relationship detection. So that's where we are. So so this is relationship detection. See now, so it is here. So till now I will stop here for a minute before I go to the next. And if you have any questions, you can ask Dr. Shailesh. Any question?
No.
Sauji or anybody else, any questions so far?
No.
Okay, so we go ahead. So here are some examples actually. So first, three type of entities. See in the box, inside the box, there are three type of entities. See, you saw in that document, it was a very comprehensive relationship of different relationships. So here we are taking three out of them. So PHYS is a code for physical relations. And physical relation describe physical proximity of taggable entities. Then PER-SOC, so personal or social relations, and ART looks like an article. Okay, so article, so whatever article is there. So this is what the three types we are representing here. See a sentence here. So we are having a sentence: when we were in Spain, comma, my mom taught me how to drive with a car. So this is a sentence. First of all, we do name entity recognition. So we see a V is represented. They are present. They want to tag V as a organization. So Spain is a GP. It's again a graphical some geographical entity. Then my is representing person entity. Mom is again person entity. Me again person entity. And car is again representing vehicle entity. Once we found this NER, then we do this kind of relationship extraction. So we is physically related with Spain. So when we were in Spain, so physical proximity. So see, again read the definition of PHYS. So physical relationship describes physical proximity. So when we were in Spain, so it described the proximity between we and Spain. So that is one relationship. So now second relationship is my mom. So it is representing a PER-SOC site of SOC, PER-SOC type of relationship, which is a personal or social relationship. Then mom is relating mom with the a car. So mom is related to a car. So article, ART. So these three relationships, there might be more relationships, but to keep the diagram representation simple, it is the example of relationship, the kind of relationship we expect. So so this is very clear what kind of things we are looking for. And tools are available to automatically do representations like this. First, they will automatically extract entities. And after that, you can go ahead and display the relationship between these entities. So that's what automatic tools are available. And there is a very nice library in Python available, which does all kind of NLP tasks. So modern library, there are two libraries. One is NLTK and one is SPACY, SPSCY, and one is NLTK. So SPACY is an older library, and NLTK is an older library, and SPACY is a newer library. So in SPACY, we can do all this kind of things available, like this kind of all available. But see entities. So entities, if you see, they are always in a context. So there are some predefined entities which you can just apply that SPACY, and automatically it will give tag these entities. But if you have suppose a medical application, so entities are very specific to medical world, right? So drug or disease name and all those kind of things. So entities are very specific to the medical world, right? So in that case, you have to train you have to specifically train your SPACY model on that new type of entities. So new type of entities, you have to take a corpus which is hand tagged. So all your entities you have to tag with hand, what represent what entity. And on that corpus, you have to train a SPACY model. If once you train that SPACY model, from the medical world, you give any other paragraph, it will automatically tag. But some standard entities like this kind of entity, these kind of standard entities anyway are ready-made available to in SPACY. You need not train any model, just call a function, pass your text, and you will get your NER done. But in very specific context, like military context or in medical context, so where entities will be different than this, right? So if the entities are different, you need to hand tag some corpus and train your SPACY model on that. So once you train that SPACY model on that, so this is supervised learning, right? So we are training a SPACY model with the help of entity hand tag. So once you train that supervised model, then next entity, if you get any new paragraph which is not tagged, whose entities are not recognized, that it will do automatically. So this is training a SPACY model and automatic recognition of standard entities. Both things will be demonstrated to you in a Python hands-on, which will come tomorrow morning. Okay. So this we are here. So relationship extraction. Once again, I am taking you to the complete NLP cycle. So sentence segmentation and tokenization are part of lexical analysis. Part of speech tagging is part of lexical analysis. Sorry. So sentence segmentation and tokenization comes under lexical analysis. Part of speech tagging, POS tagging comes under syntactic analysis, and entity recognition and relationship detection, they come under syntactic analysis. So you see entity detection and entity relationship detection is very closely related to finding the meaning of sentence. Once you find the meaning of sentence, then only you can find the relationship between entities. If you don't know the meaning of the sentence, you can't find the relationship between entities, right? If you do part of speech tagging, at this stage, you cannot find out the relationship between entities because you don't know entities, what entities are present. So once you do NER, then you are able to find out the relationships. So entity NER and relationship detection come under syntactic analysis. So this is what is your complete NLP cycle. Now, like we get into little abstract concept, I take a minute break here. And if anybody has any doubt till here, before we get into new things, I think I can give a minute break. So Dr. Shailesh or anybody else, any questions? Kauji?
No.
Any questions? So concepts
No.
are very simple. Himanshu and Soman, any questions here?
No, sir.
Really?
No, sir. It was clear.
Okay, so now we get into something called occurrence metrics. So use cases of that, what are their business use cases? That will be separate, done in deal with a separate lecture. After this, a 15-minute lecture will be there. In that we'll discuss the use cases of this. So what is the occurrence matrix? So occurrence matrix, it is some kind related to the vectorization of your words. Document, suppose you have a document, you have to vectorize it. So all these things are related to that. So suppose you have 4 films. We're talking about 4 movies here. First, see, their movies are listed in columns. Just read their names. First movie is Harry Potter and the Sorcerer's Stone. Socrator and Sorcerer's Stone. Okay. Sorcerer's Stone maybe. So Harry Potter and Sorcerer's Stone. This first movie. Second movie is little easy to pronounce. The Prestige. Third movie is Wolf of Wall Street. And Hangover is another movie. So 4 movies we have listed. And we have some reviews related to this matrix. All these movies, some reviews are there, which we have picked up from, say, Twitter or so any review, like a review site. We have picked up those things. We have done tokenization, removed the stop words, those things we have we have converted to lowercase, punctuation, comma, all these things we have removed. So these basic hygiene we have already followed. And after that, we found that we have only 5 words in our vocabulary, just to keep things simple. Usually 5 words will never be there. Your words may be 5,000, 500,000, those kind of numbers you have. If you analyze this kind of movie reviews, so you may have 5,000 words, 500,000 words, or 1 million words also you may have. But right now, just to keep things simple, so suppose that your bag of words has only 5 words after doing all pre-processing. Only 4 words, 5 words are there. One is fear, beer, fun, magic, and wizard. So only these 5 words are there, just to keep things simple. And this is your bag of words. So bag of words was something which we discussed in our very first lecture. So if bag of words is something what we have forgotten at this point, I'll suggest you to look at the first lecture PPT or the first lecture video. So bag of word is nothing but after removing stop words, whatever remains, unique words. So that collection is called bag of words. You remove stop words and whatever remains, unique words, all unique words collection. So that is called your stop words. So that's what we have stop words here. So stop words are listed on the row like first is fear, second is beer, third is fun, and then magic because it is a Harry Potter movie. Wizard, so wizard again maybe because of Harry Potter movie. So these are all only 5 words we have. So now you have movies as 4 movies as 4 columns and 5 words in bag of words, like 5 distinct words are there in bag of words. So that is your complete bag of words. So only 5 words are there, suppose, to keep things simple. So you listed them in row. So they are listed. So you have a table now. So now you see the first entry. Corresponding to fear row fear, the entry in Harry Potter movie is 10. What does it represent? So it means all the reviews which are related to Harry Potter, fear is repeating 10 times. Frequency, fear is repeating 10 times. Similarly, beer. So beer, when I talk in context of Harry Potter, it is not repeating single time. So beer is repeating only in Wolf of Wall Street 2 times and hangover. So hangover is definitely related to some kind of alcohol hangover. So Beer is repeating 8 times in Hangover. Similarly, we see the wizard word. So wizard word in wizard when we talk in context of Harry Potter, it is repeating 10-20 times. So quite natural, quite natural to have wizard word repeated more times in a Harry Potter magic movie. So it is repeating 20 times. In the Prestige movie, it is repeating only 8 times. And Wolf of Wall and Hangover, they do not have it. So entries, whatever entries are there, corresponding frequencies, they are corresponding frequencies. So this matrix is called a occurrence matrix or a term document matrix. So as I said, its use cases we will discuss in a later class. Okay. So is this concept understood? Because very simple concept. Is this understood? Documents like movie is a document, like Harry Potter is a document, The Prestige is a document, then all the reviews related with Wolf of Wall is a document, and all the related reviews related to Hangover is a document. So documents we have listed in columns, and all the bag of words, unique words we have listed in rows. And whatever entries we are giving, so there are corresponding frequencies which are occurring in this particular document. So is this particular simple concept understood?
Yes.
Dr. Shailesh?
Yes. Yeah.
So this is one concept which is called term document matrix or occurrence matrix. So this is one particular concept. So now what is the use of that? So see the use of that. So Harry Potter document. So you have document like just I'm calling this movie by short form. So Harry Potter movie. So what is the vector representing a Harry Potter movie? So fear into 10 times, beer into 0 times, fun into 6. See the column entries. Fun into 6 times and magic into 18 times and wizard into 20 times. So my vector for Harry Potter movie is 10, 0, 6, 18 and 20. Is this understood, Dr. Shailesh?
Yes.
And similarly, can someone tell what is the vector corresponding to Hangover movie? Someone, what is the vector related to Hangover movie?
So beer and fun both repeating 8 times.
No. You have to tell completely. Fear into 0, beer into 8, fun into 8, magic into 0, and wizard into 0. So magic, wizard, and fear multiplication with 0, so they will disappear. So it will have beer into 8 times and fun into 8 times, only that much. So now Himanshu, tell me the vector for the Prestige movie. What is the vector for Prestige movie?
So fear 8 times, beer 0 times, fun 5 times, magic 25 times, and wizard 8 times.
Okay, so now you got the vector for. So now let us consider only 2 movies. One is Harry Potter, one is Prestige. So we have vectors for them. So the vector for Harry Potter movie is 10, 0, 6, 18, and 20. And Prestige for the Prestige, it is vector is 8, 0, 5, 25, and 8. So we take a dot product of it. Dot product we all understand by our 10th and 11th vector algebra. So dot product is nothing but the corresponding elements we take and take a multiplication. So see the third bullet here. Third bullet. So 8 is multiplied by 10, so 80. Then 0 multiplied by 0, so it is 0. Then 6 multiplied by 5 is 30. Then 20 multiplied by 8, then 450. Okay, 18 multiplied by 25, 450. And then 20 multiplied by 8, it is 160. So got it dot product. So we take a dot product of it. So we got a dot product 750, 720. Now you will ask me why we found this dot product. So what I will tell you, you find the dot product of every pair, like with Harry Potter with Prestige, Harry Potter with Wolf of Wall, then Harry Potter with Hangover, then Hangover with like every possible combination of 2 column pairs, you find the dot product. So what it will give? So whatever dot product you get, it will tell you which movies are very closely related. See which movies are closely related. So eventually we find that we take all the dot products and we find that Harry Potter and the Prestige dot product is 720. That is the maximum. And see, they are all related to magic because both maybe, see Harry Potter also, magic is repeating 18 times and the prestige also magic is repeating 25 times. So both are related to magic. So this dot product shows, number shows which movies are very closely related. So we find that maximum dot product belongs to Harry Potter into the prestige vector dot product. So that is, they are most closely related. So that is the use of a particular this particular term document matrix. So similarly, if you have emails, so emails also you can put, one is ham and one is spam. Ham means bad emails, spam like spam. Ham is good email and spam is a bad email. So two columns we have, and related to bag of words you put in the rows, and just try to like find out a dot product. So it will give you some kind of relationship between a very crude example I am giving, but this, from this example it should be very clear what is the use of this term document matrix. So each document, so if we combine all Harry Potter's reviews, so when call it a document, so it is one document. All the reviews combined to the prestige movie, they are one document. So similarly, we have 4 documents. So we have 4 document vectors. So now we want to find out which movies are closely related. Once we see this movie, a human mind can anyway tell which movies are closely related. But for a computer, you need this kind of tools, juggleries, and tricks to find out which movies are closely related. So their dot product is closely related. So these movies are closely related. So that's how you find. And suppose you have watched a movie Harry Potter and the Sorcerer's Stone. You watched on Netflix. So Netflix wants to throw a similar movie to you because it Netflix thinks that you are interested in magic movies. So what movie it will throw? It will throw the Prestige movie at you because it is a similar movie. But it will not throw Wolf of Wall Street. It will not throw. Looks like it is related with Wall Street. It is related with finance. And Hangover. So it is Hangover is related to alcoholism or something like that. So it will not throw these 2 movies at you. So automatically the Prestige movie will be thrown at you that you have watched this movie. This is also a similar movie. Do you want to watch it? So this is how that is one of the use case of occurrence matrix. Okay. So now we go to the next concept. Next concept we go consider the following text. So you see, look into this text. Second bullet here. So there is a bird sitting on a wall. So for first sentence is there is a bird sitting on a wall, and the cat is sitting on fence. So there are 2 sentences. The bird is sitting on a wall. The cat is sitting on fence. After that, we do all stop word removal, all hygienic syntactic processing we do, and we do lemmatization also. So all pre-processing done. We are left with vocabulary, which is bag of words, our vocabulary. So vocabulary we are left with bird and sitting and wall. Bird, sitting, wall from the first sentence, because there is a or stop words, on a also stop words. So bird, sitting, wall. So these are the words we got from our first sentence. And second sentence, similarly we get cat and fence. So see, the also stop word is on the all stop words. So we get cat and fence from the second sentence. So from this document, the document which was having 2 sentences, we are getting these 5 words: bird, sitting, wall, cat, and fence. So now here what we do, both we do a square matrix. So row also we put all these 5 words, and column also we put all these 5 words. So like 5 by 5 square matrix. So 5 by 5 square matrix, and we see which terms are occurring together. So you will see that bird will always occur with bird because it is a self, right? So all diagonal terms will be 1 because cat will always occur with cat. So all the diagonal entries will be 1. Now in the first sentence, bird is occurring with sitting. So bird is occurring with sitting. So bird is occurring with bird. So see the first row on the table. Bird is occurring with bird. So 1. So bird is occurring with sitting because in the same sentence it is occurring. So 1. So bird is sitting with wall. Bird is sitting on a wall. So in the same sentence it is occurring. So they are co-occurring. So wall also, bird and wall 1. and bird is not occurring with cat and fans because it is another sentence. So they will be 0, 0. Similarly, we do which, so similarly you see the cat sentence, cat. So cat is occurring with sitting because sitting is there in cat sentence also. Then cat is occurring in cat is occurring with cat, obviously one, and cat is occurring with fence. So that we are entries. So which terms are co-occurring, we are marking them as 1. So this is called co-occurrence matrix. Is it clear to everybody? See, occurrence
Yes, sir.
matrix, we were listing document and all the term frequency we were noting down. But here we are not doing that. Here we are doing something different. We are doing all the pre-processing, finding bag of words. Same we are putting in column, same we are putting in rows. So it's a square matrix. All the diagonal elements will be 1. And in the one sentence, whatever co-occur, we'll mark them as 1. Dr. Shailesh, it is understood?
First row, bird sitting on a wall. So sitting, why sitting is vertical column is 1 for all.
See, because sitting is occurring in both the sentences. No, we have only 2 sentences.
Okay.
And sitting is occurring in both the sentences, right?
Yeah, yeah.
So it will be 1. So
Okay.
see, bird sitting on wall. So bird is occurring with sitting and wall. So bird is to bird. Bird is to word is always 1. So bird is to sitting is 1 and bird is to wall is 1. Bird is not occurring with cat and fan. So that will be 0. Understood?
Okay, okay. Yeah.
So this is a simple concept which even I think a middle school guy can understand. So I am telling these are very, very simple concepts. So you should know what is a co-occurrence matrix. So this is what called co-occurrence matrix. And there is one more concept called skip-gram based. So this is I think one of the last concept which I want to explain today. Skip-gram based. So this skip-gram based is little tricky. So now you consider here this particular document, which is highlighted in yellow. So man stumbled seconds, Dashle man clock set knocked ground. It is some sentence which at least is not making any sense to me, but this sentence has been given. So assume that this is a sentence which is making sense. Might be if you are very great at English, it might be making sense to you, but it is not making sense to me at present. But it is some valid sentence. Man stumbled seconds, Dashle man clock upset knocked ground. So this is our sentence. So see, whatever we have done is, so we have again put, or maybe this is our bag of words. So that's why it is not having any is or the, and it's not making any sense. So it looks mostly, it is your word vocabulary, bag of words. So all we are doing, man also we are, similarly all the words we are putting, like in co-occurrence matrix here, we are putting both all the full vocabulary in the rows and full vocabulary in the column. Is this understood, Dr. Shailesh?
Yeah.
Dr. Shailesh.
Right, right.
So we are putting all the words in row and all the words in column. So again, it's a square matrix. So diagonals will automatically be 1. Then we are discussing something called skip gram. So 3 skip and 2 gram. So I'll tell you the meaning of skip and gram. So first of all, we'll form a here to find the co-occurrence matrix. Here to find the co-occurrence matrix, our window was one complete sentence. If sentences are co-occurring in a complete sentence, whatever the length of the sentence, if it is co-occurring, then we are marking them together, occurring together, 1, 1. Now here we are reducing our window. And window means now here at a time we'll look at only 5 words. So 3 plus 2. So 3 skip 2 gram means 3 plus 2. Only 5 words we'll look at together at a time. We'll not look at complete sentence or complete document, whatever. So we'll look at only 5 sentences, 5 words together. How 5? 3 skip plus 2. So 3 plus 2, 5 words. So 5 words will look together. Skip means we'll take up all the pairs which are having maximum 3 words in between them. So it will be very clear from you when we'll take the example. So we'll take all the words pairs. So 2 gram means at a time we'll consider only 2. In a particular pair, we'll consider only 2. So that is 2 gram. Skip means we'll consider only the words which are maximum 3, which have maximum 3 words in between them. So first of all, in this sentence, you consider first 5 words. So what are first 5 words? The first 5 words are man, stumbled, second. So man, stumbled, second 3, and Dursley and man. So these are 3 words. 5 words total. Man, stumbled, seconds, Dursley and man. So these are 5 words we have taken. See now how we are forming the pair. So first pair is man and stumble, because distance is less than main stumbled, main second, because in main and second there are only 1 word. Then main Dursley, there are only 2 words in between them. Then we are taking man. So in between man there are 3 words. Between man and man there are 3 words. So we are taking 2 pairs, and maximum distance should not be maximum. We should have 3 words in between them. So understood? First sentence here. I will highlight it. Here. Dr. Shailesh, have you understood whatever I told? See, first you highlight this first. So I have taken first 5 words. Man, stumbled, seconds, Dursley and man. So these are first 5 words I have taken. So first 5 window I have seen. Window of 5. So the first window is man, stumbled, seconds, Dursley and man. So how we have paired them? Maximum should be 3 words. Minimum is anything is okay. So man, stumbled 1 pair, man, seconds 1 pair, man, Dursley 1 pair, and man 1 pair. So why man 1 pair? Because in between man and man there are 3 words. So maximum 3 words, that's what we will look into. So is this understood, Dr. Shailesh?
Yes. Yeah.
Someone, can you explain this?
Sir, yeah, I understood this, but actually I have one question.
Yeah.
The 3 skip 2 gram, that is clear. Actually, I'm a bit confused about the matrix here. Is the matrix matrix is the general co-occurrence matrix or something related to
No.
this?
Matrix will derive from these pairs. Matrix
Okay,
is
but here
wait. Yeah, we'll come to matrix. Don't go to matrix right now. First, see the pairing. Then see these 5 words. Stumbled, I have highlighted. Yeah. See, stumbled. Then seconds. Then Dursley and man. This see 5. Then second pair is stumbled second. Stumbled Dursley.
That's clear. No
Himanshu, is it clear to you? Dr. Shailesh, is it clear to you?
Yes, sir.
Dr. Shailesh?
Yeah, it is clear, but this, when we have bag of words, then why this main will repeat twice?
That use case will come to later. Yeah, don't come to use case. First, understand the concept here. Right now, I'm explaining you only concept. So now this is some little different from co-occurrence matrix. So now man and stumble are occurring together here in first. See this first one here, first one. So man and stumbled are occurring together. So we'll mark man. See, we'll search for man in this matrix and see stumbled. So a particular cell will mark as 1. Then man and second. So man and second also co-occurring in the same bracket. So we will mark man and second as 1. Man and Dursley is occurring together. So it will mark man Dursley as 1. And then we'll say man. So man will always be 1. So similarly, second row if you see, stumbled. Say second row, stumbled is occurring with seconds. So that is marked as 1. And then stumbled is occurring with Dursley. So that is marked as 1. Then stumbled is occurring with man. So that is marked with 1. And stumble is marked with clock. So that is also marked as 1. So now is it clear, Soman, to you how we derive this matrix?
Yeah, I think I'm still confused about the matrix indices, because
indices will be always 1 only. And at a time to mark that 1, we'll see only this much. Only 1 bracket we'll see. If they are occurring together in 1 matrix, that cell will mark as 1. Is it understood?
Okay, sir, but here man and ground has no relation.
There might be
There is no.
somewhere there, yeah, down the line. See here, man and ground you have. So you have to derive all kind of relationships.
Okay.
See, you have man
Yes,
and
yes,
ground
correct.
here. See here, man and ground is there.
Okay, okay, okay.
So you have to derive all kind of relationships.
Hmm.
Understood? See here, man and ground is there. So that's what we mark 1-1. But if you see knocked and knocked and stumbled. So knocked and stumbled, if you see that cell is 0. See knocked on the row, if you see knocked in the row and stumbled in the column. So that is 0. So you see there is no relationship which is no pair which is knocked and stumbled. There is no relationship which is having knocked and stumbled together. So that's why it is marked as 0. So this is called co-occurrence matrix. Dr. Shailesh, is this understood?
Actually, it is very confusing.
Why confusing? Yeah, tell me, no. What is not understood?
Actually, first 5 means we are taking first 5, then we are again traversing to next 5, right? Maybe
The next 5, yeah, stumbled and this, the next 5, then
Yeah.
next 5, then next 5, next 5, like
Right.
this. Then third time this, then this next 5, like that. And then we are traveling to this next 5. And once this is over, then we'll keep it a cycle. So if ground is considered, so ground will be 1 and main stumbled and Dursley will be, so it is taken in a circle. So ground will be the first here, in the last one ground will be the first and another 4 will take from this first one. So it is put in a circle. In a circle we are putting them, all the end of 5, 5, 5 we are taking.
Okay, okay.
Is this understood fully now, Dr. Shailesh?
Yes, yes. Yeah.
So they are put in a circle actually, circular thing. So last one when we come to ground, so then ground will be 1 and these 4 will be taken together with that. And we'll detect all the pairs here. So this is called 3 skip 2 gram based, and its usage will be clear to you in the next class, and a couple of things we'll take in more. This is very useful thing. So right now you understand only the concept. So this is how co-occurrence matrix skip gram based. So it is skip gram based. So 3 skip. So 3 skip means maximum 3 words can be there in between 2 words. Maximum. Minimum can be 1, 2, 3. Maximum 3 words. Gram means in 2 brackets pair, co-occurrence pair, we'll consider only 2. So these numbers can vary. So it can be 3 skip 3 gram, 3 skip 4 gram, like that it can become complicated. But you don't have to worry. All these calculations are done by your algorithms or computers. So you understand this one concept, I think that is enough for you. So I think with this we end today's class. So these some few concepts I wanted to explain you. And if you have any questions, I think you are more than welcome to ask the questions. So any questions, Dr. Shailendra? I think you are still confused in 3 skip and 2 gram. Are you?
Actually, this dot matrix and all that is clear. So that I was able to correlate because of the number of occurrences and relation and product was
Yeah,
giving
that was
some
very
sense.
simple now. That was very simple.
So that was giving some sense because of the magnitude of the dot product. And also correlation.
No,
is
here we have not explained you any use case. No, there we had a use case example, so we explained you. Here we just explained you the concept that what is co-occurrence matrix and what is the occurrence matrix. Just concept is explained to you, and its use case is not yet explained to you.
Okay.
So don't get into use case. What is the use case? And in case of occurrence matrix, occurrence matrix, I had a use case, so I explained it to you. But in case of co-occurrence matrix, I have not explained you any use case. And in case of scriptgram also, I have not explained you any use case. I have just explained the concept that what is a co-occurrence matrix and what is a scriptgram based co-occurrence matrix. So right now, don't get into use case. Don't get confused with that. That will come. Keep little patience. Is the concept understood?
Yes, yes, yeah.
Both co-occurrence matrix and skipgram based co-occurrence matrix. Is this understood?
Yes, yes.
If you have understood that for this class, that was the planned thing. So you are okay, you are well there, no problem. So we will get into next class and then we will understand things. So